Hey guys! Welcome back to our discussion session. So this week we are going to discuss about quiz 2, thermochemistry. Altogether we have 3 different questions from this chapter. And let's get started with the first question. In the first question, you were asked to estimate the specific heat of sample of copper from the fact that 64.0 joule are needed to raise the temperature of 15 grams of copper metal from 22 degrees Celsius to 33 degrees Celsius. So you are about to estimate the specific heat of this sample. So this is a rather straightforward question. You need to use the formula Q is equivalent to C delta T, where T is the temperature and then Q is given to you in the question, which is 64 joule. So Q is 64 and then the C, you need to calculate the C, and delta T, the temperature. So you need to always remember that the temperature that you're going to calculate must be the final temperature minus the initial temperature. So 33 degrees Celsius minus 22 degrees Celsius. Alright, from here you can calculate the value of C, which is 64 divided by 11 because of 33 minus 22. So you shall get the value of C equivalent to 5.8181 joule over degrees Celsius. Okay, this is the first part of this question. And then from here, because you were asked to estimate the specific heat, right? The specific heat, so it means that you are going to find the value of S. So how are you going to find the value of S? So you are going to use the formula C equivalent to MS. So you already calculated the value of C, which is 5.8181. So the mass in the question, you were given the mass of the sample. So the mass is 15 grams of copper. So you're going to use the mass 15 grams of copper. So 15 times S, which is the thing that you want to calculate. Therefore, your S is equivalent to 5.8181 divided by 15. So your S is equivalent to 0.3879 joule over degree Celsius grams. So this is your final answer. So in this question, you should get 6 marks. So how you can get that 6 marks? So this one, 1 mark. Another 1 mark here, and the first part is 3 marks, right? 1, 2, 3, and then another 3 marks is the same concept. So formula 1 mark, and then you show your calculation is 1 mark, and your final answer will be 1 mark. Altogether will be 6 marks. Moving on to question number 2. A 50-gram sample of water at 100 degrees Celsius was placed in an insulated cup. Then 25.3 grams of zinc at 25 degrees Celsius was added to the water. The temperature of water dropped to 96.68 degrees Celsius. Determine the specific heat of zinc when the specific heat of water is 4.184 joule over gram degrees Celsius. So how are you going to do this? You need to know that we have 2 different things. One is water and the other is zinc. And then you need to remember the conservation of energy, where energy cannot be created nor it can be destroyed. So it means that the total must be equivalent to 0. So what we can do is that we need to write MS delta T, MS delta T plus MS delta T equivalent to 0. Right. So what is MS delta T, MS delta T? So you have 2 different things. One is for water and the other one is for zinc. Alright. So when you have done this, so you need to use back all the information given to you in the question. So for water, we are going to start with water. At first, the mass is 50 gram of sample. This one, your M is 50. And the temperature, at first it was 100 degrees Celsius, right? And then the S of water is given here. But remember here you need delta T, means that the delta T is final temperature minus initial temperature. So from here we can have all the values for your H2O. So I'm going to write here, so 50 times the specific heat 4.184. So delta T, final temperature, the temperature of water dropped to 96.68. So 96.68 minus the initial temperature is 100. Alright, so we settle with H2O. So all this need to plus the 1 for the zinc. So the 1 for the zinc, given to you, the mass of the zinc is 25.3 gram of zinc, and the zinc is initially at 25 degrees Celsius. And then it says that when you put the zinc inside the water, the temperature of water dropped to 96.68. It means that the zinc shall be at equilibrium with the temperature of 96.68 as well. So what you can do is that the mass of the zinc from the question is 25.3. So times S for the zinc is the one that you want to calculate, and then delta T is the final temperature minus initial temperature. So final temperature is at equilibrium, right? So it should be the same. So 96.68 minus the initial temperature of the zinc, which is 25 degrees Celsius. So you just need to calculate this is equivalent to 0, law of conservation energy. So after this, you need to press your calculator. You should get negative 694.544 plus 1813.504 S is equivalent to 0. Therefore 1813.504 S is equivalent to, so this one bring back equivalent to 694.544. So your S is equivalent to 694.544 divided by 1813.504. So you get your S equivalent to 0.3829 joule over gram degree Celsius. So this is the final answer. So altogether you should get 4 marks. So here 1 mark, and then you put the correct value, it should be 1 mark. You show me the calculation, 1 mark, and the final answer shall be 1 mark. Altogether 4 marks for the second question. Moving on to question number 3, the last question. Using the following information, infer the mass of HF must react in order to produce 345 kilojoule of energy, assuming an excess amount of SiO2 are used in the experiment. So here we already told you that the SiO2 are the excess reagent, so it means that this is the limiting reagent which will dominate the formation of the product. So from here we are going to use this ratio, means that 4 mole of HF, it will need, here 4 mole of HF, it will need negative 184 kilojoule to produce the product. So it means that we can rewrite this 184 kilojoule will produce 4 mole of HF, right? So, but in the question, 345 energy. So, the mass of HF that should react, right? So, if you want to produce this much, 4 mole of HF should react in the reaction. So, you have more than 184. So, you have 345 kilojoule, right? So 345 kilojoule. So how much more of HF should react to get this much of energy? So 4 divided by 184. Don't worry about the minus sign. It's just an endothermic or exothermic process, right? So don't worry about that. So 4 divided by this times 345. Therefore, you should get 7.5 mole of HF. It means that you need to have 7.5 mole of HF. Then only you will produce this much energy. But if you read again the question, infer the mass of HF. So what you have already calculated is actually the number of mole. So from the number of mole, you can get the mass, because number of mole equivalent to mass over RMM. So you already know the number of mole is 7.5, the mass. So what is the RMM for the HF? So you need to use this table. Make sure that you use all the numbers from this table, okay? So you're going to find H and you're going to find F. So hydrogen is 1.0079 and F is fluorine, supposed to be 18.9984. Right, so you're just using the 4 decimal point, right? So now, because it's just one H and one F, so 1.0079 plus, for the F is 18.9984. So the mass should be equivalent to 7.5 times, because this one you need to add on, so it's going to be 20.0063. So the mass should be equivalent to 150.0473 gram. So this is the final answer for the last question. So altogether you should get 6 marks. So the first thing, the ratio, you will get 1 mark, and then you need to show me how to get the mole of HF that you need. So the calculation and the final answer, and then you convert from the number of mole to mass. So it means that you use the correct formula, 1 mark, and then you put the correct values and the final answer. So altogether 6 marks. Okay, I hope you understand all the 3 questions from the quiz section. So I'll see you again next week for the next chapter 3. I wish you all the best and see you soon.